Lesson 88, multiplying and dividing rational expressions. What you see pictured here are some rational expressions that we're going to be multiplying together. Remember, rational expressions are in the format of a fraction, and so we are going to be simplifying these expressions. Let's take a look at our first examples. Here, there are a couple ways of solving these. We could multiply the numerators times the numerators and the denominators times the denominators and then simplify, or we could simplify first and then multiply. For this one, I'm going to show how to simplify first and then multiply. And one way to determine that is if you can see common factors in the numerator and the denominator, then you can easily simplify those. And that's what I'm going to do here. So I know that I can divide a 3 in the denominator and get a 1, divide a 3 in the numerator here and get a 2, because 6 divided by 3 is 2. Now on the other side, I can divide a 7 here and get a 1. 21 divided by 7 is 3. Now, if I look at my x's, I know I have x to the 4th divided by x to the 3rd. These three x's can cancel off. Now I have 1x left right here. And because I have 1x, because remember when we divide like bases, you subtract the exponents. So 4 minus 3 is 1. Now I have x to the 1st and x to the 1st down here. These cross off. And now I only have this x squared left over. Y squared divided by y squared, or 2 minus 2 is 0. So those cancel off. I have 1y up here. That cancels off. That leaves us with 2 on the bottom. And then I can just now multiply across. So 2 times x squared is 2x squared. In the denominator, I have 3 times y squared, which is 3y squared. And so I would be left with an answer of 2x squared over 3y squared. So that was one method. The other method I'll do with this, the second example here, where I will just multiply across and then simplify. So 5 times 4 is 20. X to the 2nd times x to the 2nd is x to the 4th. Remember, when you multiply like bases, you add the exponents. And then the denominator, 7 times 9 is 63. Y to the 4th times y to the 3rd is y to the 7th. And now I have to look to see, are there any common factors in the numerator and the denominator here? And in this example, there aren't any common factors in the numerator and the denominator. So our answer would remain as 20 x to the 4th divided by 63 y to the 7th. Next one. I can already see that there are no common factors in the numerator and denominator, so I'm just going to multiply straight across. So 6 times 3 is 18. X squared times x is x cubed. Divided by 5 times 7 is 35. Y to the 4th times y squared is y to the 6th. Again, I can just double check to verify there's no other common factors, and there's no common factors between 18 and 35. And there's no common factors with our variables either. One on the right-hand side, we do have common factors. So I can divide a 14 here and divide a 14 here. That they divide each other off to become 1. I have 1q here and I have 1q here. They can divide each other out. I have q to the 8th divided by q to the 3rd. These three can cancel off. That leaves me with 5 left here. And then the z's. I have z to the 4th and z. This one cancels off and I have 3 left over here. these 5 can be gone, and I have 2 left here. And if I have 3 z's on top and 2 on the bottom, these 2 can cancel off, and that leaves me with 1 z left over. And now I can multiply across. Now I have 5q to the 5th z divided by 3. And so that would be my answer. Actually, this would not be 5. This would be 4, because we have the 4 here. So 4q to the 4th. So 4q to the 5th z divided by 3 would be our final answer. Next, 9 over 3x to the minus 15 times x squared minus 2x minus 15. So these we're multiplying a rational expression by a polynomial. The first step in solving these is make sure you factor when you can. So in the numerator of the rational expression, I can't factor, actually I could factor something out with a 9. I can factor a 3 out. That leaves me with 3 left over here. The reason why I'm doing that is because in the denominator, I can factor out a 3, and I am left with x minus 5. And then I'm going to multiply. Remember, this is all over 1. So I'm just going to put that so I can distinguish my numerator from my denominator. And then I have a trinomial in my numerator. What 2 numbers can I multiply to get negative 15? But add them together gives me a negative 2. That would be a negative 5 and a positive 3. Now that I have factored everything, I can find factors in the numerator and denominator that are similar or the same that can cancel each other off. X to the 5th, x minus 5 and x minus 5 divide each other out. And now here, 3 and 3 divide each other off. And all I'm left with is 3 times x plus 3. And then our last step would just be distribute, and this would be 3x plus 9. And this would be our answer. Next one, factor. And it might help to factor out the denominator first. So if I factor out a 2, that leaves me with x minus 9. And now I can see, can I take a 2 out of the 6? I can, and that leaves me with 3 in the numerator. And then over here, I know it's over 1. I have a trinomial on top. 2 numbers to multiply to get negative 27, but add them together gives me a negative 6. That would be a negative 9 and a positive 3. Now I can simplify. The 2's divide each other off. X minus 9 and x minus 9 divide each other off. And I'm left with 3 times x plus 3, which gives us an answer of 3x plus 9. Next one, 16 over 4x minus 32 times x squared minus 5x minus 24. So here I can factor out the greatest common factor. So 4, that leaves me with x minus 8. 16, I can take a 4 out of that, and that leaves me with 4. And with my trinomial, I'm going to factor that. What multiplies to get negative 24, but add them together gives me a negative 5. That'd be a negative 8 and a positive 3. And now we can simplify. The 4's divide each other off. X minus 8 divide each other out. I'm left with 4 times x plus 3, which equals 4x plus 12. And this would be our answer. Okay, our next one here, multiply rational expressions containing polynomials. So again, just factoring out where you can first and then simplify. So in the numerator, the first one, I know I can factor out a 2, m, and n. And when I do that, I'm left with 4m plus 1. And in the denominator, I can take out a 2m, and I don't have anything left. Well, I have a 1 left over in the denominator. Over on the other side, I'm going to do the denominator first. So I can take out a 6n. That leaves me with 4m plus 1. And the numerator, I can factor out a 3, and that leaves me with 5 left over. And the reason I'm factoring a 3 is just because I know that 3 is a factor of 6. So now let's simplify. 2 divided by 2 is 1. M divided by 1 is 1. I can divide a 3 here. That gives me 1. Divide a 3 here, and that gives me 2. I have an n over here and an n over here, so they divide out. I have a 4m plus 1 here and a 4m plus 1 here. They divide out. And all I'm left with is 5 divided by 2. And this would be our answer, 5/2. Next one, here, let's factor first. Your other option would be if you just multiply straight across, but then you're making numbers a lot bigger. It might be a little bit difficult to simplify. So here on this side, I know I can factor out an m. That leaves me with 3m n plus 2n. I'm also going to take out, I'll take out the n as well. And then the denominator, I have a 2m. Over here, I can take out an 8n. That leaves me with 3m plus 2. And then the numerator, I just have 11. So now this m and this m divide out. I have this n and this n that divide out. And I have a 3m plus 2 here and a 3m plus 2 here. So now all I have in the numerator is 11. And in the denominator, I have 2 times 8, which would be 16. So our answer would be 11/16. Next one, factor out the numerator. I can take out a 2 and take out an m. That leaves me with 4 plus 3mn. In the denominator, I know I can take out I'll just leave this. I can take a 2 out here, and that leaves me with 6. And then on this side, I can factor out in the denominator an 8m, and that leaves me with 3 plus n. And in the numerator, I have an 8m. Now to simplify, 8m divides out with 8m. 2 divided by 2 is 1. And then I can check to see if there's anything else in common. There is not anything else in common, so I would just distribute the m. So I would have 4m plus 3m squared n all over 6 times 3 is 18 plus 6n. And that would be our answer. If you wanted to, you could have just kept it without distributing it. So you could have just had your m on the outside here, and then just have your 4 plus 3mn all over 6 times 3 plus n. That would be okay as well, either one. Next one, dividing rational expressions. So when we're dividing expressions, especially those that are in the form of a fraction, remember you need to flip the second fraction and then multiply. So before I do anything else, that's what I'm going to do first. So it's 5st to the fourth divided by 4s squared t. And I'm going to flip the second one. So it'll be 2s cubed t squared all over 15s squared t. Now I can go about simplifying. I can look to see if there's anything in common first. So I know I can divide a 5 here and divide a 5 here and I get 3. I have t squared. This t squared can divide out this t and this t because there's 2 t's on the bottom. I know I can do s squared and s cubed. That leaves me with 1s up here. I can divide this 1s out and I have one less s down the bottom, and then this s divide out. And now I can multiply straight across. Actually, I can also simplify 2 here, get a 1, divide a 2 here and get a 2. And now multiply across. In the numerator, I just have t to the fourth divided by 2 times 3, which is 6. So t to the fourth divided by 6. Next one, let's rewrite this one. So we have 9r squared minus 12r divided by 27. Flip the other one and multiply. So this would be 1 over 3r minus 4. So from that point, I'm just going to factor. I can take a 3r out in the numerator. That leaves me with 3r minus 4 all over. I can factor out a 3. That leaves me with 9 left over times 1 over 3r minus 4. Since we broke everything down with its factors, I can find common factors to divide out. 3 divided by 3 is 1. 3r minus 4 divides out with 3r minus 4. And I'm left with r divided by 9. Next one, 8j squared k to the 7th divided by 15k to the 7th, j to the 4th divided by j cubed k divided by 5k j to the 6th. So let's rewrite this. So I have 8j squared k to the 7th divided by 15k to the 7th, j to the 4th, multiplied by, flip the second one, so 5k j to the 6th over 6 j cubed k. Okay, now I can factor. See, it's factor out first. Actually, I can simplify. I can divide it 2 here and get 3. 8 divided by 2 is 4. 5 divided by 5 is 1. 15 divided by 5 is 3. And look at our variables. This k and this k divide out. I also have k to the 7th here and k to the 7th here, so those cancel off. J squared divides out, and now I have 1 here because I had 3. And now I have 6 j's on top, and I got 5 total j's on the bottom. So if these 5 cancel off, that means I have 1 j left over. I can multiply straight across. Now I just have 4j over 9. And this would be our answer here. Now, if you want to multiply straight across first and then simplify, you may do that because as you can see, it does get pretty messy with everything crossing off and trying to find what do I multiply with each other. So that you may want to do. Now let's look at some application. A business makes a profit of x to the fourth divided by 100x squared plus 100x dollars for each item sold. If x squared plus 5x plus 4 items are sold, what is the total profit in terms of x? So if they make a profit of that amount for each item sold and they've sold these, so we're going to be multiplying those two expressions. So x to the fourth over 100 x squared plus 100x times x squared plus 5x plus 4. This is all over 1. So I'm going to first factor. So now I know in the numerator, in the denominator, I can take out 100x. That leaves me with x plus 1. In the numerator, I can take out 1x, and that leaves me with x cubed times, I can factor the numerator. Two numbers to multiply to get 4, but add them together gives me 5, so that's a positive 4 and a positive 1. This is all over 1. Now I can simplify. X plus 1 divides out with x plus 1. And I have an x here and an x here. They cancel off. And I'm left with an answer of x cubed times x plus 4 all over 100. And I don't need to distribute it. I'll just keep it this way. So that would be our answer. And our last one here. Fran makes a profit of x squared over 20x squared plus 10x for each ticket he sells. What is the total profit in terms of x if he sells x squared plus 9x plus 20x? So again, I'm just multiplying those two expressions. Okay, now I'm going to factor, so I can take an x out in the numerator and have x left over. And I can factor out a 10x. That leaves me with x plus 1. And I can factor the trinomial. Two numbers multiply 20, but add them together gives me 9. Is 5 and 4. And now simplify here. Only the x's cancel out. And so here I'm left with a bigger answer. So I have x times x plus 5 times x plus 4 all over 10 times x plus 1. And then I noticed when I factored out, this should have been a 2x. So there's a 2x here. Because when I take a 10x out of the 20x squared, I would have a 2x left over. So our answer would have in the denominator 10 times 2x plus 1. So this would be our answer. That is our lesson today on multiplying and dividing rational expressions.